Hello everyone, welcome to TryWrite, the new era of learning. Myself, Rafiq. So let's move to the topic. Today we are discussing about Navi's-based classification algorithm in machine learning. Okay, so the Navi's-based algorithm is a classification algorithm based on Bayes theorem. The algorithm assumes that features are independent for each other. Okay, uh, which is why it is called Navis. It calculates the probability of a sample belonging to the particular class based on the probabilities of its features. For example, a phone may be considered as smart if it is has touchscreen, okay, internet facilities, good camera, etc. Even if all those features are dependent on each other, but all those features independently contribute to the probability of that phone is a smartphone. Okay, so in average base is nothing but the chance of the probability which we gain, what we gain. Okay, we see in many of the terms we see the probability of the chances in many predicting. Okay, classification predictings. Okay, so for that we assumes the chances, how much the probability of the win rate or lose rate or accuracy rate. Okay, so like that we were predicting the Navi's base. So in this we has a Gaussian algorithm and uh, multinomial. Okay, so key features of Navier-Space classifier. Okay, the main idea behind the Navier-Space classifier is to use Bayes theorem. Okay, Bayes theorem is nothing but finding the probability. Okay, to classify the data based on the probabilities of different classes given the features of the data. It is used mostly in high dimensional text classification. Okay, example, Navier-Space classifier is a sample probabilistic classifier, and it has very few number of parameters which are used to build the machine learning models that can predict if at a fast speed and other classifier algorithms. Okay, it is a probabilistic classifier because it assumes that one feature is in the model of in is independent and other existence of the another feature. Okay, in other words, each feature contributes to the prediction with no relation between each other. Okay, Navier-Bayes algorithm is used to spam filtration, sentimental analysis, classifying articles, and many more. So spam filtration is nothing but email spams, fraud messages, so, like that, we are finding the probability chances, and sentiment and analysis is nothing but the reviewing statement. So, it is nothing but a part of many reviews generated. Okay, if we let us take an example in sentiment analysis. Sentiment analysis is nothing but in a little example I will explain you. If you make a movie, okay, based on the reviews, if you the who watched this movie, the person will use the review and rating to the movie. Okay, based on the overall, if it 100 members or 1,000 members give the reviews and rating to that movie, based on all of those the 100 and 1,000 members, it calculates the probability of the who will give the average, excellent, average, below average, not bad like that. From analyzing that all the gather information, it predict a emoji. It predict a data like sentiment analysis, like it's good, it's excellent, based on all the calculation of the probability. Okay, like that, sentiment analysis works. Okay, so Navier-Bayes is a probabilistic classification algorithm based on the Bayes theorem. It assumes that the features are independent. Okay, the both features are the Navier-Bayes features are independent of each other. Okay, they don't know each other relationship, which is why it's called Navies. Okay, deposit that assumption is it's performed the well in many real world applications, especially in text classification, spam filtration, sentiment analysis like that. The Navispace mostly using email spams for detections and numbers identification, weather prediction, face recognition, and news. Okay, we all know that in news and in news channels, we all know they predict the next week news climate also. How can they predict? Because they use the climate analysis methods by using probability sticks and many of the methods they use the prediction methods. Okay, further data science also is included. So predict the tomorrow's weather like that. We are predicting the probability chances. It may be sunny, it may be rain, it may be cool climate. Like that, they predict depends on today's weather. Okay, so most of the from his childhoods we are listening the probability sticker from the tenth in inter or in polytechnic or in BTech. We almost know about the probability of flipping a coin of the heads and tails, probability chances. Okay, you all know that. Okay, probability of 1/2. Right, we has a chance of one head, two statements. One head we have two chances, head or tails, like that. Pick a random. So in most of the we probability using cards. Okay, pick a random card. What is the probability of the getting a queen? We have a 13 cards in each symbol. So in that we have a queen of one, like four queens. In each 13 cards we have one queen. The probability of 13 cards in the each is 1/13 maybe. So we have a queen cards, heart, diamond, like that. So four queens, 52 total cards, and the probability of pick queen is equal to four cards overall total by 52. The chances if the 4/52 divides is equal to the chances maybe divides. Okay, each divides into 1/13, 1/13, 1/13, 1/13. Okay, for black and red and diamond for hot. Okay, it divides like that chances. So pick a random card. You know it at a diamond. You know it is a diamond. Now, what is the probability of the card belongs to a queen? If you pick a particular card of diamond, it has. If you pick one card, the remaining all has 12 cards to pick up. Okay. From the probability chances, we have hold one card and remaining to 12 cards. It remains 13 cards. The probability of taking one card has a queen. Okay. Let's see. Total diamond cards we have 13. Okay. Queen is one. At the end of the we find the queen. Okay. In here we pick one card. We don't know what card we picked. So the chances we remains, we have the chances of 13, okay, by picking the queen card, okay. In the 13 chances, we don't know in which case the queen will be opened. So it is called the way the statement is called conditional probability, okay. P of queen by diamonds, it divides, okay. The probability of P of A by B, probability of event A, knowing that the event B, okay, A depends on the B, okay, overall the total has already occurred. So Thomas Bayes, he is the founder, is the inventor of the Navi's Bayes classification and the formula, and see P of A by B and P of B by A and into P of A by whole B, P of B, okay. So P of let's calculate the method. P of queen by diamonds. We are dividing the statement and dividing the formula into P of diamond by queen and P of queen by P of diamonds. It gets the overall calculations of the probability chances we have. So we can see P of diamond queen, we have 1/4 chances, right? If we divide the diamond 12, we have the four chances, okay? Four cards overall diamond. If we pick diamond by queen, we have four cards, diamond, heart, like that, okay? So we have the probability chances of 1/4. If we take P of only queen, we have in diamond we have 13 cards. So the probability chances maybe 1/13. Same see diamond 1/4. So overall we are calculating the formula and final we get the 1/3 probability chances of the getting queen. Let us understand you get the basic idea of the what is what about the Navi's based classification. So in that we are kind of we let's take an example to get the more easily to understand it in coding. So let us take a Titanic example for Titanic. We have a Titanic. We all know about the Titanic story. The number of passengers were alive, were dead. How many members were dead in few years ago. We all know about the Titanic story. So based on the story, we have a data of Titanic's passengers, who passengers is alive and who are saved, and like that we have the data females and males, their ages. So depends on data, we can predict the calculation of probabilities, how many males were saved and how many females passengers were saved from the incident, saved from the info, incidents. Okay. So let us see the passengers list. So we separate the data, like we have the passenger ID, name, P-class, and the gender, sex, and age, the slip, pass, ticket, fare pay, and cabins. Okay, from the divided way, survived. How many members are survived from the incidents? Okay, male and class and age and cabin and fare pay. Overall depends. Okay, we assigned it the male and class A. All the data will assign into the one variable. Okay. Make an Avis assumption that future search has a male, class, age, cabin fare, etc., or an independent of the each other. Okay, Or let us see the data. Show. So like this, we have the data of the Navi space classification data. If any case chances, I will mention in the description this data. I'll mention the data into the description. You please check out. Or we can see here Navi space split data. From this data, we want to make the how many members, how many males and sex, how many males and females were say, survived by the incident. Okay. Here we only have the group combine of like column of sex, and in that we have combine of male and female. We didn't know how many males or how many females or survived. So we want to separate this column. Okay, we want to do the dummy of this column and make the clean and crystalline clear table to understand the better and easy to the machine. Okay. For that, we all know the open the Jupyter, and I have already opened it, and see I import the pandas as PD, and I read my path here. I mentioned here path to read the file of the data. See the we have the file here, and from this file, we didn't want the passenger, great survivor. We didn't want these. Okay, so name, sex, age, sleep, parts. We didn't want this these IDs. We only want survivor. So we want to remove these columns. So removing the columns, we use df. We all know about it. We all know that. Sorry, df dot drop. Which columns you want to drop it? You can drop the columns. I want to drop the passenger ID. Okay, I want to drop the passenger ID, and I want to drop the names. I didn't want the search of the columns because it is necessary data. So from this, I want the gender because I want to do separate for this. So I don't did the I didn't want to drop the name column. Sorry, six column. And for age, one word. Okay, let's you. Let's put the age in it. We don't need to remove the age. We want that age. Let us see. I want to remove the patch, and I didn't want ticket also because we didn't calculating on probability on ticket because we didn't doing the chances of probability of ticket. We just doing the probability for male and female who were survived. We create a model. For that model, we predict the data and just know watch. We don't want the cabins and we don't want the fair pay also. And parts, I removed parts. Okay, tickets were okay. I didn't. Yes, I removed parts too. So I removed cabin and okay, I removed this. Okay, let's put the fare in it. Okay, I didn't want to remove the fare. Okay, I want to remove a axis now. Remove a column. Column input in place. Sorry, not input. In place equal to true because we did. I didn't want to disturb the data. So, like if I print the data whole data, I didn't want that whole data. I just mentioning the head of only top of the data I want. Let us take. Okay, right. Wait. Did I did mistake? Name of the columns. Okay, so wait. Column spelling may be mistakes. I didn't mention N here. Okay. Okay, see. We remove the date of The unwanted data we removed from unwanted columns. Okay, unwanted columns we remove from the data. Okay, now we have some simple and clean, some little bit clean data from these survived. I think we didn't want any survived data, like because we are predicting the male and female from the survived. So let us remove the survived data also. We know that first we want to remove the survived data too. Okay, it is one known column, so it doesn't need any. Okay, so we are up to 891 rows. Okay, we have the now we have clear and some bit little bit clearer data. From this data, I want to make a dummy data for male and female. I didn't want this fair age like that, so I want this male. In this, we can watch here the six column is only having six column. In six column, we have only male and female. I doesn't want like that. I want separate male and female. How many males are there? How many females are there? Okay, like that. I want data. So for that, I creating a dummy data for that. For I created a variable called dummies. For dummies, I am giving pd dot get dummies. I am giving inputs for size. Okay, yeah, inputs. Name inputs. I didn't mention any input here. Okay. I didn't mention input here. So for that pasting, I would copy the code and paste here. For wait, and remove the code here. First, I want to create a input. Okay, for that I'm taking inputs hashtag inputs fix equal to inputs dot fix mapping. I want to doing mapping for all them. For here this key. From here I'm taking mail has one. If it is true, it maybe it present the data into one. For female, I'm assigning two. Okay, okay. I will present the data like this. Okay, now it's it. I'm creating input data. Now we can create it simple. We can happily create the dummies. Sorry, here not getting this input dummies. Okay. Now we can easily import the inputs from here because we already assigned the variable here inputs.six, so we can easily import from there. From these, I'm making dummies. Sorry, dummies dot six. Dummies dot. I want to represent data has. I want only 40, not 40. Just try now 4. Yeah, what's happening? Inputs is name. Inputs is not when I mentioned the inputs here. Okay, is hashtag function. Wait, I didn't mention any df. Okay, for survived column, I didn't give input. Okay. I didn't mention the inputs. Okay. Here survived column. I directly assigned the survived column. So here I want to put inputs here. and directly survived column imported, and I want to mention the target. I didn't mention target 2. What happening today? I'm getting directly going on flow. That's why I get a little bit target equal to df dot survived, right? I'm assigning the if we are removing the target, we are assigning to direct the target for target variable. We are assigning to the x. Okay. Yes, I assign the df equal to target. Yeah, it's okay now. It's run completely. Now we can happily run the code. Still, it's getting name objects, no attribute calls x. We already mentioned here. Oh, I think the mention of the s is wrong because we have a capital variable here. So I put the no small s. I think that's the reason here. So let's wait. Let's run the code again. See, okay. Nothing to worry. I just mentioned directly. I entered the data as six. I didn't copy here from that. Here we have a capital S. So it does not recognizing the table column table. So that's why it getting error. If we if I, get- I assign the capital S, then it easily recognize the column. So we can see here we have the dummy data of us. So from the dummy data, we have the true and false. It may be some if some members try this code, they maybe get or zero or one or two because we are assigning one or two. If the system for the machine learning, false means zero and true means one. We all know that in binary statements and bit code. So for that, true means one, false means zero. Okay, we has a one like that. We can count zero, one, one, zero, one, zero, one, zero. Okay, for that. Now I want to concat it. For the dummies, I want to concat I want to enter this into this table. Okay, I remove this column and I want to create a neat and class table. Okay, so for that, I will again giving concat for the functions inputs equal to pd dot concat. In that, I mention the inputs and I mention dummies. Again, access equal to direct column. Okay, okay, okay. See, we have the p class sex. We have a column sex and male. We get the separation of the data. Okay, now from the sex column, we get the male and female. Now age. Now we didn't want the sex column, right? We already had the data of male and female. So let's drop the sex column. Input dot drop. It doesn't want this to also drop the males because we are characting the female. So we assign the target. So we don't want to drop these two. Okay, in fair we directly do this. Now we have the pair of females and the age and the class ticket and the fair pay. So from this, we can see any missing data in it. We can check the any missing data because we want to check that because while doing the while running the while trying to the model or trying or test to the before model before pre-processing, like we want to check any null values or any missing values. So for that, I want to check it. What index age? In age column, we have we think had a null value. Wait, let us print input start. I want to put like any. Let's take first 10. Let's print 10 of the data. Okay, we can see here we have an AND value here 5. So here we have one missing data. We want to fill it for. We want to fill the data. Okay, for fill we use fill null. Okay, if we want to, it's take the fill null by average, not by forward and backward. We take in because we are clearing data, so we want to just average of the data of the age. Inputs dot age dot fill null inputs dot age dot and doing by the mean of the data. Okay, because I didn't want to. If I fill forward fill, its age will be 35. But if I fill backward fill, its age will be 54. I doesn't want the um like that. So I'm calculating the overall the age of that and need to calculate the average age of the passenger. Okay, take here input dot head. No, okay, now it's now see we can see. Okay, no, wait. I want to check the if the here we get the value of 5, right? Wait, see here the value of 5. From the 5 we want to check like head equal to IU 10 again. From here, okay. See we can see the age here we get 29 here. Average. Here we can see the NAN value 35 and 54 between 35 and 50, we get the average value of the age of the person. Okay, we get all the we have the all clear data. Now we want to build a model in Gaussian method. So first we want to select the we want to train the data, right? First we want to train the data. For the training data we mentioned from sklearn doesn't recognize it. From sklearn dot model selection, we were importing. We also know train test split method. From this model we are importing train test split method, and we also know here we want to train the data here x train x test y train here and y test here. From this data we want to again do the train. In K-fold we discussed about it. We are split the data into for try when we are training the data, we are split it by parts like K-fold. We use K-fold method here. So for that we are splitting the data, assigning X as inputs and my y has target and test size I want to mention. I am using test size as 20. So I take 30, 0.3, 30% of the data I'm training it. So from this I want to make again build it. Okay, I want train from this I'm creating a scale and model. So you can see the test data too. Here I creating a model navis as where's import. Here I using Gaussian method and we can use multinomial also. I want to create a model here. Let us wait to take. Okay, now it's fine. The model will recognize it. So further, we want to train the model for here. MP of it. Here we're training the X and Y. From here, we are creating a model. See again, yes, the Gaussian method. We have created the model. Okay, now we can here easily predict the score of the model dot SCOR score here from X train and Y train. We can see the test. First we can see. First is the test, not train. We're checking. First we want to check the train and test data. We want to the know the score of the. I get 71% of test data. So I want to check what test data is tested. So I'm assigning zero column to 10. So okay, it's trying like okay. And I want to check the y2 also how from where y is taking. Okay, y taking 8 from 0 survived column. Okay, y is up. Okay, we get the y value too. Now we want to predict the model dot predict x test by 0 to 10. I'm predicting here from here. Okay, array we get the array value 0 1 1 0 0 1 0 0 means we have a false true true false false true false like that we get the data here. From this data, we want to predict the model of the probability chances. From Navis base, we want to predict the probabilities. I think the data must be in array. We have a bit of data here. From this data, we want to create another. We want to do the cross validation method here. So what I am taking again sklearn from model selection, sklearn model selection. I'm importing cross validation class validation score. Okay, for this score I'm taking for what class calculation you want. For I want the Gaussian method here because I'm calculating the score of Gaussian NB, right? So for that I'm taking it. Again, I want to take X train for this model, and same as Y train, and same as CV. I'm equal to giving 5. Now it's completed. So now can see the easily 78%. It gets 80%. It gets 76%. Like that, we get the cross validation. Okay. Like this, we create the probability. Here we predict the probability of 0 to 10 chances. It gets the 1 off to 5. Like we calculate that we have the 10 values. In the 10 values, we have the one value has 3. Like we calculate the 3 by 10. Like that. Okay. It gives a probability. Okay. Survived. Here the probability we can see the 96 0 0 0 0 here probability chances. So we get the score value here as 76% for this model. So I think I hope you understand this too. Code. Okay. So even okay, I hope you guys all understand about this Navis based classification. Thank you all of you.